Okay. Last time I talked about periodic table. And remember, there was a geologist who came up with this first before Mendeleev. And he started off as a review, started off with one single dimension. He just lined up all the elements at the time. And he noticed that certain things started repeating, like unreactive gas, unreactive gas, unreactive gas. And that's how we started splitting that one-dimensional line of elements up into a two-dimensional table. Like that. Okay, so last time we talked about a neutral atom. A neutral atom has equal numbers of electrons and protons. That means there's no charge. That's because the charged particles balance one another. Protons are positive, electrons are negative. When those numbers are equal, there's no net charge. So the atom is neutral. Now, what if they're not neutral? What if the number of protons and electrons are not the same? Well, if the number of protons is greater than the number of electrons, then we have a net positive charge because the positives outweigh the negatives. And the charge is by how much? So we have a net positive charge, and that is called a cation. An easy way to remember that is the T on the cat. Looks like a plus sign. If the number of electrons is greater than the number of protons, it's an anion. So it's got a net negative charge. Think of the N and the anion is like negative. The difference is the charge itself. So, for example, what's the net charge there? This is the more complicated math. 8 minus 6 is, yeah. So you have 2 electron surplus. So the charge on this ion is -2. Now, you can write it like that or like that, either one. When I was in high school in 1966, when I took chemistry, this is the way we learned it, and I've been doing it that way ever since. A lot of books will show it like this, though, but bottom line, it's a -2. All right, so the worksheet I gave you, one of them is what we started doing last week. The other one is with ions. So in your notes on the periodic table, some of the elements like to form cations, some like to form anions. And It's the way the electrons are organized within the atom determines whether they like to be an anion, whether they like to be a cation. It all has to do with stability reasons. Remember, I've always stressed stability rules the world. If it's more stable, it'll go that direction. If it's more unstable, it won't. You have to put energy into it if you want to change it to something that's unstable. Okay, so on the periodic table, we mentioned this before, the cations now are going to have one extra proton if it's this one. Two extra protons if it's the alkali earth metals. Three protons if it's the boron family. This is B up here. Going the other way, the halogens here want to be a -1 anion. Under oxygen, -2. Under nitrogen, -3. And under carbon, doesn't form ions. Now, the reason why everything in the column, once like in the alkali metals, first column on the left, the reason why they all want to form a +2 is because of the valence electrons are the same. Same setup. Remember we said there's core electrons and valence electrons. Valence electrons determine chemistry, not core electrons. So if the chemistry is the same, that must mean the valence organization is the same, which is true. So if we were to pull up this was a worksheet we did last week. And it's just one of the pages that I gave you today. Neutral, that means the protons and electrons have to be the same. So what's the charge on the boron here? Right here. Is there a charge? No, because electrons, protons are equal. So neutral atoms, protons and electrons are exactly the same. No exceptions. As soon as you heard the word neutral, or if you don't hear the word neutral, in this class, you can assume it's neutral. I will always tell you if it's an ion, always. Because you got to know the charge to determine the number of electrons, just like her question at the beginning of class. How do you tell the number of electrons? Okay, so let me do one of these real quickly again. Remember, atomic number of protons are always equal, no exceptions. So we have atomic number and protons equal. On the periodic table up there, what is element 31? Gallium. And the bottom number is the number of protons. The superscript is atomic mass for that isotope. Well, this is protons plus neutrons. So we have protons plus neutrons, that's 68. The top number here is 68. So that isotope is gallium 68. So why don't you grab your worksheet and start working on the neutral one. I'm going to pull up one for the ions in a second here, and I'll show you how to work that one. Are there any questions about this worksheet? The worksheets I gave you, if you turn it on the back, are all the answers. So I'm not going to give you points for doing something where I give you all the answers. Okay? So the title up here, it'll say ions or neutral. Make sure you get one of each. Anyone have any questions on this neutral worksheet? Now this is under Canvas files, unit 1, both of them.
How are we supposed to know the date?
How are you supposed to know the names? In your lab packet, there's a periodic table with names on it. Or if you have really good eyes, never mind. That one doesn't have it. Want to take a picture? Oh, in fact, it seems like I saw. the same one as in your lab packet. Does anyone else need a periodic table with chemical names on it? I have a few up here, but if you have your lab packet, there's one in your lab packet. Now for 1A, your periodic tables will not have the names in it. These all don't have names. Huh? No, yeah. They're tiny. You've got good eyes. Not this one. Thank you. Anyone else need one? The writing is really tiny. So all of you are nice and young. You have good eyes. I Sure. All right. Now this first worksheet you should be very comfortable doing. You will have something like this on the test. You have like 4 of these. Not 4 worksheets, but four rows. Okay. It's definitely going to be on your first test. Does anyone else need a periodic table with names on it? Yeah. Yeah. I always include one on the test. Pass one back. I'm going to give you the pack here. All right. Who's got at least half of it done? Raise your hand. Okay. Let's do ions. Now, ions are very, very similar, except for one big difference. Is the protons and electrons are going to be different. Hence, there's going to be a charge on the element's symbol. So the first one is with boron, and it says it's got, okay, atomic number of protons, those are still the same. So boron, you look on the chart up there, it's what, 5. The atomic mass is still the same, protons plus neutrons. So that's going to be 11. And then the name of the isotope is boron 11. So that's exactly the same as with the neutral worksheet. Now, the number of electrons is going to be different on this one. Plus, we have to account for the charge. So this says it's a charge of +3. That means it has 3 extra protons. So when we compare the electrons and protons, there has to be more protons than electrons. How many more? 3 more. So we have 5 protons We can't change protons. Only thing they can change are electrons. So how many electrons do we have? 2. Because we have to have 3 more positive protons than electrons. As we add those together, it's got to come up to positive 3. Now, does that make sense? Okay, let's do the next one. 11. So you look on your handy dandy periodic table, and remember the atomic number is part of the square that the element's in. So you find a number 11 up there, and a number of 11, of course, it has 11 protons as well. What's the symbol for 11? Na. Okay, so we need to put atomic mass for Na 24, a number of protons below, and what is the charge on Na? +1. You look at protons and electrons, which is more? Protons means it's positive by how many? By 1. Now, you can write that like this, or you can write it like that. You put +1 or 1 plus, or just the plus sign. The 1 is assumed. Got to be careful with assumed stuff, though. All right, and we write this. Sodium 24. How many neutrons? 13, all right. I notice at the top I tell you they're ions. I've got to tell you there are ions. Sometimes I don't, but in this class, I will always tell you that. All right, that's what we're doing. What time is it? It's 1-ish. That's what we're doing the rest of the lecture here. Are these 2 worksheets. And remember, the answers are on the back. And if I gave you a periodic table, keep it.
It shows 38 protons and 38 electrons.
Don't go by the decimal number now.
No, but in the answer, you see other.
Is it this one here?
Yeah. See?
So let's find 38. Here's 38. Oh, yeah. So this should be.
Mm-hmm. And charge will be -1.
Yeah. I didn't realize.
Here and in your table, we got 38 protons and 38 electrons. So it's different numbers.
I mean,
Of course.
Oh, it's flipped, isn't it?
Yeah.
That's the same as that? No.
Yeah, it is. But
Yeah, so there's,
not here. So we got
right. Glass on number 4, fourth one down,
mhm.
there is an error on that. So for now, if you have lab today, I can show you the correction. For now, don't do number 4. Thank you. Finally.
on my list.
Oh, that's how I get pens in this class.
625, but it's only
Oh yeah, right. This needs to be what?
and like on the front, this is already in. So it's not like, so you can't just increase. So it should be 95.
Fifth one down.
So
Let me see. 95, that's right. Positive 1. What is, yeah, so this should be 95 up there.
yeah. So I thought.
So did you correct this one?
Not yet. But,
I don't know how, the problem is I have like 10 versions of this floating around. Some I've corrected. And what was that? Let's see, 4, 5, 6, 7, 8, 9, 10. So 4 and 10, you guys, those are optional. Okay.
Also, another thing I've been struggling with the online.
It's not online.
It's not.
You have to get it at the student store.
So it's like,
It's not very much, but anyway, it's cost of photocopying.
okay. It's,
So just make sure you get over there before next week. You can do the write-up. Has anyone bought their packet like yesterday or today? Lab packet. Wondering if we had enough over there. Huh? I'm saying? Sorry again? No. When did you buy yours? Right, but when? Oh, all right.
Like a week before.
Yeah, I just wanted, someone bought it recently. I just want to make sure we have enough over there. Otherwise, I got to provide a digital version. So is this making sense?
For the most part. One question I was having was, like, how did you know how did you figure out there's 2 electrons on boron? How did you know? Because on this one, obviously it's 5, but I know it's gonna be different on this sheet.
Okay. It's going to charge a positive 3.
Yeah,
That means it has 3 more protons.
okay.
So the protons are 5. You can't change that. So for electrons, if there's 2, that means there's
Okay.
3 more protons than electrons.
So there'll be 2 more protons.
Yep, exactly. Yeah, one more electron.
Okay.
So then that would be 70 then.
Gotcha. Okay.
That makes sense?
Yep.
Cool. All right. This makes sense. Now, if you have Friday, if you're not going to stay for Friday, and this makes total sense, you don't have to stay. I'm not saying go, but you're welcome. Huh? Did you have Friday lab? Okay. And does this make sense? Okay. Um, does dry lab last week make sense?
I don't have to take the lab.
I'm just reviewing stuff today for Friday. No, well, that's next week. And if you have Friday lab, and you don't want to come to the review, yes. Yeah, you need to come fully set up for next week, including your pre-lab. Your Friday lab? Okay, do you understand all this stuff really well? Okay. You're welcome to come if you like. Hmm? No, no, because we have to catch up the Saturday lab people, so it's not fair to, yeah.
Well, I want to make sure it's right. If electrons are greater than protons, it's a negative charge, and if protons are greater than electrons, it's a positive charge.
Correct.
Yay. Okay, I got it. Thank you.
Well, this stuff makes sense now?
Yeah.
I know,
Maybe
right,
I'm also printing out all of the work. Now I still have these two, but I'm printing out all of your worksheets and just going through them like, sorry.
you
And then
have,
my stuff and then going against the answers.
you have lab today?
No, I don't. I have it tomorrow.
Stop by and I'll give you another set of problems to
Perfect.
practice on.
Okay, all right, thank you. Let's start with the lab.
Yeah. Actually, I have them with me. Why don't you just come down here and go? Okay, so to figure the charge, you look at these two. So this is more than that. That means it's going to be positive by 2, by 3. Right, right. Yeah, looks like you're doing fine. Sure. It's like dry lab 2. And that's, yeah, everyone needs to practice on that.
If we're done with the worksheet, you can go.
Are you going? Do you have Friday lab?
Wow.
Wow, okay. This is what I was passing out today. Optional. If you want more practice.
So just optional.
Correct. Yeah. Sure. Sure.
Our pre-lab write-up, does that go, do you put that inside our lab composition notebook?
Yeah.
Okay.
Yeah.
Okay. Also, I'm the one that's been emailing you about textbook issues and trying to like instruct the AD, and I can't. Now, I don't know what to
Well, I
do.
got a response from Pearson,
Okay.
and then they didn't answer my question enough. And so, oh, we're here to help.
Okay. Absolutely necessary to have textbook at this stage right now. Sure.
Well, I mean, the textbook, it's a good textbook. It really. Well,
I like it.
I know, but it's crazy that I'll bug them. The problem is it's Friday. Let me write him another email.
in the lecture. You guys show us where, I don't, maybe I missed it.
Oh,
Where
let me do one thing. I need to stop the recording.